Today we're going to do our last solving exponential equations lesson, and this is as complicated as these are going to get for what we're going to look at this year. So, what looks different than what we've done in the past? We now have fraction bases. So, sometimes people get really scared of fractions. They're nothing too crazy here, I promise. All you need to think about is negative exponents. So, thinking back to when we talked about exponents before, we know that we have a negative exponent that's the same as 1 over the positive version of the exponent. So as an example here, if I have 4 to the negative 2, that's the same as 1 over 4 squared, which is 1 over 16. We're going to kind of work in the reverse order for that today. If you see something like 1 over 16, you're going to change it to 4 to the negative 2. So if you see a fraction, that's your clue that you're going to be using something with a negative exponent. You can still use your table of exponents. You'll just have to remember, okay, look for the bottom number of the fraction in your table of exponents and then make the exponent negative. So I will walk you through that when we get to some examples. We know we're going to have some negative exponents here. Other than that, everything's exactly the same as what we've been doing with solving these. So nothing we can't handle, I promise. So the first thing we want to do is we want to make the bases on both sides match. So for a second here, ignore the fact this is a fraction, just look at the bottom number of the fraction, 6. What base can I use for both 6 and 36? And that base would be 6. 36 is 6 squared. 6 is the same as 6 to the 1, so to get 1 over 6, I need to do 6 to the negative 1. So since 6 to the 1 is 6, 6 to the negative 1 is 1 over 6. Now let's sub those in. This turns into 6 to the negative 1. Keep the exponent you have there on the outside. 36 turns into 6 squared, and keep that exponent you have on the outside there. Now let's use power to power. Distribute. Negative 1 times negative 2a is positive 2a. Over here, our new exponents are negative 2a minus 4. This looks more like things we've been seeing in the past. Now that we have the same base on both sides, cancel those out and solve the equation you're left with. So to solve this equation, I'm going to add 2a to both sides and divide by the number in front of a, which in this problem is 4. So for our final answer, we end up with a to the negative 1. Process is very similar to what we've been doing. The only thing that's changed is we do use negative exponents for fractions. Let's try another one. So looking at this one, when we look at our table of exponents, we'll be looking at 216 and then just fiddle with it and make it negative to make it work for 1 over 216. So what base can I use for both 216 and 36? The base I can use for both of those is 6. 36 is 6 squared. We actually just saw that in the last problem. 216 is 6 to the third. So to get 1 over 216, I'm going to do 6 to the negative third, or 6 to the negative 3. So now let's replace those. This becomes 6 to the negative 3. Keep the exponent you already have. And 36 becomes 6 squared. Simplify this right here. When I multiply negative 3 times negative 9, or 3x is positive 9x. Other side, there's nothing to do at that point. Since I have the same side on both sides, base on both sides of the equation, I can cancel those and solve this equation right here. All I need to do is divide both sides by the number in front of x, and we get x equals 2 over 9. To finish out this lesson, we are going to do 2 more problems. Those 2 problems are going to be similar. They're going to have fraction bases. They're just going to be slightly more complicated because we'll have to use product over quotient rule at some point. But don't worry, I'll walk you through them, and really it's similar to what we've been doing. If you can handle these, you can handle anything. Okay, so for these last 2, just like we saw in the first two fractions here, which means negative exponents will be happening somewhere. So this first one is one where you could go a couple of different ways. 64 and 16 can both have a 2 base or a 4 base. So I'm going to go with the 4 base option. If you use the 2 base option, your work in the middle will look a little different, but your final answer will be the same. 16 is the same as 4 squared. 64 is the same as 4 to the third. And then to get 1 over 64, it's going to be 4 to the negative 3. Since 4 to the third is 64, 1 over 64 is 4 to the negative 3. So let's replace all of those things. Don't forget to use parentheses where you need to. So for anything that already has an exponent. From here, power of a power, let's distribute. We get 4a here. Keep the base the same. This becomes negative 6a minus 6. Other side, there's nothing to change yet. From here, remember, we're going to use our product rule. When we multiply two things with the same base, we add the exponents. So we are going to add these exponents here. We write the 4 base just once. I'm thinking 4a plus this exponent, negative 6a minus 6. If you'd rather, you could just write this as 4a minus 6a, because plus and negative is the same as just subtracting. Whatever works for you. At this point, we have the same base on both sides, written only once, so we can cancel them. Can also combine like terms here. 4a minus 6a is negative 2a. And then we just solve it out like any other equation. So I add 6 and divide by negative 2. And we get a equals negative 3 over 2. Or if you like decimals better, that would be negative 1.5. The very last one we're going to look at might look a little scary because we have a fraction on top of a fraction. We will deal with both of those fractions individually. Take it one step at a time. It'll work out, I promise. So if you're looking at your table of exponents, we are looking for 243, which we'll adjust for 1 over 243 in a second, 27 and 81. What base can I use for all three of those numbers? The base we're looking for is 3. I'm going to work a little out of order here. 27 is 3 to the third. 81 is 3 to the fourth. And then 243 is 3 to the fifth. So 1 over 243 will be negative 5 exponent there, 3 to the negative fifth for that 1 over 243. So let's replace things. This becomes 3 to the negative 5. Keep your exponent you already have. 27 becomes 3 to the third. Keep the exponent you already have. 81 becomes 3 to the fourth. From here, we need to do a whole lot of distributing. So distribute a negative 5. Oh, I wrote the wrong number there. That should be a negative 15. 3 times negative 5 is negative 15. Got a little ahead of myself. Distribute a 3 here. My dog is snoring in the background, just ignore him. And then here, distribute a 4. Lots of distributing. Okay, from here, sort of like the last problem, but only the opposite now. Instead of adding our exponents here, remember that when we have our quotient rule, division means we subtract top exponent minus bottom exponent. So that's what I'm going to do with this here. I'm going to write my 3 base once. Top exponent is negative 15x minus 10 minus, I'm going to use parentheses here because I'm subtracting more than one term, this whole thing, negative 9, instead of subtracting 9x minus 6. Other side stays the same. Let me get this out of our way. So from here, we have the same base on both sides of the equation. 3 bases get canceled out. I'm going to start simplifying what I can here. So this becomes negative 9x and positive 6 when I distribute the negative. You could skip to here without writing this in between step, as long as you remember that you need to subtract both of these things, aka distribute a negative to both of these things. Other side, nothing to do yet. From here, let's solve our equation, combine our same side like terms. So I get negative 24x minus 4 when I do that. And then let's solve. Let's get our x's on the same side. And then get our numbers on the same side. Adding 8. Last but not least, I need to get my variable completely by itself. So to do that, I divide by the number in front of x. 4 over 16, if you would like to reduce that as a fraction, is 1/4. So your answer is 1/4, or if you would rather write that as a decimal, 0.25. Like I said, this is as crazy as we're gonna get with solving exponential equations. The only thing that was different today was whenever we had a fraction, 1 over something, we used a negative exponent. Still use your table of exponents, just change it to a negative exponent when you have a fraction. That is it. Have a fantastic day.